In this video, we will do some applications of this formula. Remember that we are calling this function the original function, and we are calling this function the UA shifting of f of t. Then this formula says that the Laplace transform of the UA shifting of f of t is equal to e to the negative as Laplace transform of the original. And something that we will need to do is to know how to find out the original if we have the UA shifting of the function, and if we have the original, how to find this. Then we have to go back and forth. As a first application, let's do the Laplace transform of UA of t. We already have done this, but let's do it using this formula. In this case, we can take, if we apply it in this formula, if we take the function f of t equal 1, then the UA shifting of that function would be UA of t, and anytime you see that t here, you replace it by t minus a. But here it's just, there is no t, you get just that. And then this formula says that the Laplace transform of UA of t is equal to e to the negative as Laplace transform of the original, but the original is this function, and we already know that this is the Laplace transform of 1 is 1 over s, and we get e to the negative as over s. This is something that we already knew, but we are doing it using this formula. Let's do another formula. Laplace transform, let's do u4 of t times e to the t minus 4. Then we have the u4 shifting of a function. What is that function? And remember that if you want to find the original, the procedure is to forget about this part, and anytime you see that t here, you replace it with t plus 4 to go from here to here. Anytime you see that a t in the original function, you replace it with t minus a, and if you want to go from here to there, then you have to forget about this part, and anytime you see that t, you replace it with t plus a. Then in this case, the original, the function f of t would be to forget about this part, and anytime I see that t, I will replace it with t plus 4, and then this is just e to the t. Then this is e to the negative 4s times the Laplace transform of the original, which is e to the t, and we already know that the Laplace transform of e to the t is just 1 over s minus 1. Then we have gotten another example of that formula. Let's do the Laplace transform of u2 of t times t minus 2. Then the question is, what is the function f of t? What is the original? And to move from the UA shifting of a function to the original, we forget about this part. The original doesn't have the UA, part u2 of t, and it's just anytime you see that t here, you replace it by t plus a. In this case, it's t plus 2 minus 2, and that means that the original is just f of t equal t. Remember that the Laplace transform of t is 1 over s squared. Then we can finish this. This is just e to the a is 2, negative 2s, Laplace transform of the original, which is t, and this is e to the negative 2s, 1 over s squared, and this is e to the negative 2s over s squared. Let's do another example. And this time let's work the Laplace transform of 6 times u3 of t sine of 2 times t minus 3. Then to apply this formula from left to right, we need to find the original. This is my u3 shifting of the function. Then to find the original, we just forget about the heaviside function. And anytime I see that t, I replace it with t plus 3. Then here we will get that this time the original f of t will be 6 times sine of 2 and t minus 3. When you replace t by t plus 3, it just becomes sine of 2t. But remember that the Laplace transform of sine of omega t is omega over s squared plus omega squared. Then we get that this is e to the negative 3s, a is 3, times the Laplace transform of the original. But the original is 6 times sine of 2t. And therefore this is just e to the negative 3s times 6 times the Laplace transform of sine of 2t, which is 2 over s squared. Omega is 2, then and omega squared is 4. Then this is just, here, this is just 12 times e to the negative 3s over s squared plus 4. Okay, let's end this video by solving a differential equation that requires the use of that formula. Let's solve this differential equation. Dy dt plus 2y equal to 6 times u3 of t times e to the, e to the 4 times t minus 3 and y of 0 equal 1. Okay, as always, we start by applying the Laplace transform on the left and on the right. Remember that we will be using this formula. Laplace transform of the derivative of a function is just s times the Laplace transform of y minus y of 0. Then here we get s times the Laplace transform of y minus y of 0, which is 1, plus 2 times the Laplace transform of y. And here we're going to apply this formula from left to right. Then what is the original? Then this is e to the negative 3s. Remember, a is 3. And here we get the Laplace transform of the original. How do we get the original? The original is just to forget about this part. And anytime I see that t, replace it with t plus 3. Then we end up with 6 times e to the 40. And then we combine these two terms. We get s plus 2 Laplace transform of y. We're going to move this one to the right. And then we get this e to the negative 3s. Laplace transform of 6 e to the 4t is 6 over s minus 4. And we solve for the Laplace transform of y by dividing by s plus 2. We get dividing by s plus 2, we get s plus 2 here, and we get s plus 2 here. Now, in order to compute the Laplace transform inverse of this, we're going to apply this formula, but now from right to left. Notice that we need to find what is f of t with the property that the Laplace transform of f of t is equal to 6 over s plus 2 times s minus 4. Because we want, here we have the e to the negative as times, and we want to see this part as the Laplace transform of f of t. Then essentially we have to do a Laplace transform inverse. The way to do this is we rewrite this using partial fractions. Let's do this here. We want to write 6 over s plus 2, s minus 4. We want to write it as a over s plus 2 plus b over s minus 4. And then this is just a times s minus 4 plus b times s plus 2 over s plus 2 times s minus 4. And then when we compare, we want as minus 4a, I'm expanding this, plus bs plus 2b, and we want that to be equal to 6. Then we set up the system of equations. When we compare the coefficient of s on the left, we have a plus b. And what is the coefficient of s on the right? Is 0. And the constant coefficient is negative 4a plus 2b. And we want that to be equal to 6. We can solve this system. We can just multiply this by negative 2 and add. If we multiply by negative 2 and add, then we get that negative 6a equal to 6, and that means that a is negative 1. And from here we get that b should be equal to 1. That means that, let me stop here. That means that this expression is just negative 1 plus 1. Right? All of this is just to rewrite. And now we can see that this is the Laplace transform of negative e to the negative 2t plus e to the 4t. Then our function f of t is e to the 4t minus e to the negative 2t. And now we can continue. Let's say here, this is the function f of t, and then we have that the Laplace transform of y equal to, I can rewrite this as the Laplace transform of e to the negative 2t plus, and using the formula from right to left, we can see that this is, let me just rewrite it, e to the negative 3s times the Laplace transform. This part is just the Laplace transform of this function, e to the 4t minus e to the negative 2t. And this is just the Laplace transform of e to the negative 2t plus, when we apply the formula, it says that this is the Laplace transform of the u3 shifting of this function, but the u3 shifting of that function is u3 of t. You multiply the function by u3 of t times, and anytime I see that t, I replace it by t minus 3. And I have e to the 4 times t minus 3 minus e to the negative 2 times t minus 3. Let me erase that part here, this part. And then the final answer, we'll get the final answer, we can combine. This is e to the negative 2t plus u3 of t times e to the 4 times t minus 3 minus e to the negative 2 times t minus 3. And that means that the answer of this is y, Laplace transform of y equal Laplace transform of that function. That means that y is this function. Then this y is e to the negative 2t plus u3 of t times e to the 4 times t minus 3 minus e to the negative 2 times t minus 3. This is the solution. Some observations. Remember that as when you are dealing with the Heaviside function, you will get that the Laplace transform of y is equal to some part that doesn't have the e to the negative as and another part that has the e to the negative as. This part is responsible for this part of the answer, and this part here is going to be responsible of that part of the answer. At the end, in this type of problems, you have to do two Laplace transform inverse, the Laplace transform inverse of this part and the Laplace transform inverse of the part that you get when you forget about this. Those are the two Laplace transform inverse, and you will see them here in the answer. Okay, I think this is it for this video.